What did you see on page 1 of the, yes, ma'am? Number 6, you got it. All right, so you have this XY axis, and you kind of have this line that does this, right? So what they want you to do is they're trying to find out f at x equals 7. So remember, this means the same thing as y. So that's like saying y equals 7. So you go up here to 7, and you go, and then you come straight down. If I do that, it looks like that's at 4. So the answer would be 4. All right. What else? Yeah.
Can you do number
5? Same exact idea. So it kind of looks like this. So again, they want f at 7, f at x equals 7. So remember, that means the same thing as y. So I'm going to go up here to 7, come over, and then down. And then if I do that, it looks like 3. So 3 would be the answer. Yeah. 7. Okay. 3 there. 6 there. Oops. Make that a little better. Okay, so they have something that kind of looks like that. They do say there's arrows at each end. So what value of x is y less than 4? Okay, so what you're gonna do. What's greater than? Thank you, thank you. Greater than 4. So remember, y is 4, so 4 is up here. So I'm going to take my arrow, and then I see where I intersect my line. It looks like at -2. So when x is less than -2, so it's going to the left, you would have a value that is greater than 4. Okay? And then the next one is, where is y less than or equal to 0? Okay? So this is here where the y is 0. So less than 0 means where would our value, what values of x is x less than or equal to 0? What values of x are, what x values are taking place when x is less than 0? So if we start here, that looked like it crossed at 3, and our x values, oh shoot, I went to the wrong location. Less than 0. Here is where our y value would be 0. So because that's the 0.6 comma 0. So what would give us negative y values? So from here to here, it keeps going forever. So as x is greater than or equal to 7, or excuse me, 6. I'm looking at the wrong thing. So if I plugged in a value here, 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 as I keep going that way, the values for the y value are smaller than or equal to 0. Okay, so 6, 7, 8, 9, 10, 11, 12 to infinity. So I could, if I wanted to write this as an interval notation, yeah, that's what they wanted. You would want a hard bracket at the 6 to infinity. So those are x values. As I go to the right, my graph continues to go further and further into the negative region, or less than 0. And then what values are y between 1 and 4? So 4 is here. and then 1. That's a 1 here. So this looks like it would be about 2.5. So what values would I have to plug in? That would be between 1 and 4. So you would have to plug in -2 to 4, 4, 4. Recommending 4, 1. So there, that's it. I'm not a fan of this problem. Let's skip the rest of this. I'm not a big fan of how this problem's worded. I will not give this to you on a quiz. What else did you see? On 103, 104. Yeah. 8? Yeah. Ooh, that's kind of a weird looking graph. All right, let's see if we can draw something that looks kind of close to that. One to 1, and then we have 2, 3, 4, 5, 6. And this is positive 1. Obviously, 0 is right here. So we have from here to here that. Then this goes up to here. And then back down to here. And then back up to, at 4, goes back up to 1. And 4.5 it crosses on 5. And then it keeps going like that. Okay. So if I were to find f at 3, so you go right here and you go straight down, it looks like it gets to -1. F at 0, so I go right here, come straight down here, so it looks like -1. And then f at 6, so 6 would have been over here. So come straight down, that happens at -1. So that's what I would have done on that. So it looks like there's some minimum values there. The domain of this function, the arrows go both left and right. So the domain of this function will go from -infinity to +infinity because of the arrows. And then the range, my lowest y value appears to be -1. My highest appears to be +1. And they're both like they're corners, not a smooth graph. So my range is going to go from -1 to +1. And because we have nice corners there, we're going to have square brackets. What else? What else did you see? Yeah. 4? So number 4, they tell us that h at x is equal to 14 minus 8x. And they also tell us h at x is equal to -2. So we know that h at x is the exact same thing. So that means they're the same function. So I'm going to take what this is and is equal to that. Those cancel. So -8x is equal to -16. Divide each side by -8. So x equals 2. Okay? Anything else you'd like to see on this homework? I know you had a day off yesterday, or some of you might have come. I don't know. We're good? All right. Let's go to page 105 of our notes, please. All right. So we want to start going through and talking about things where things are linear or things are not linear. Linear means it means a straight line. Straight lines can go right to left. They can have positive slopes, negative slopes, slopes of 0. Undefined slopes is a vertical line. So is this linear or not linear? This is not linear because it's curved. The ends both go up. Okay? But then it gets a little tougher on this one where you're like, okay, is that linear or not? So the rules for linear basically mean, could I move things around and get a y and an x and a number? And the answer on this one is, if we went through and we cleared our fraction where this would be 30 minus 2x minus or equals 15y plus 40x, and then I could go plus 2x plus 2x. So you get 30 equals 15y plus 42x. Yeah, my x values and my y values are not underneath a square root sign. My x value and my y value are not raised to an exponent other than 1. My x and my y values are not denominators. My x and my y values don't have radical signs or square root signs above them. So this one is indeed linear. Okay? And then it says, hey, is this linear or not? So a lot of times when you look at this kind of situation, you want to see if there's a distinct pattern that takes place. It looks like each one of these I count up by 2. Agreed? 0, 2, 4, 6. Okay, this is a good sign, so they're not spaced out awkwardly. Well, now we have to just make sure the spacing between the y's, between the x's was 0, 2, 4, 6, but here is a difference of 6, difference of 18, difference of big number. Okay, so this one did not count up normally, so this is nonlinear. So we had a definite pattern on the x, but the pattern on the y did not happen. Yeah.
Why did you say multiply by 3?
Oh, is that what it is? Yeah, so that's going to mess things up. That definitely messed things up on that. Because if I had graphed this, here, let's do this. I don't want that one. I don't want this one. I don't know if this one's going to kick up. Cancel. Yes. All right, well, somebody, let's go here. Stat, edit. Let's get rid of this. Clear. 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 So my x values I'm going to call an L1. It's just list 1. So that's 0, 2, 4, 6. Is that right? And my y values were what? 3, 9, 27, and what? And 81. Okay, let's go y equals. Let's clear that out. Let's go zoom stat. Oops, I got to turn my stat plot on. Oh, got the wrong list. List 1 and plot 1. Let's turn you on. I'm going to go list 1 and list 2. Zoom stat. So when you look at that, it kind of looks like it's jumping up quickly. It kind of sort of looks like it falls into a line, but it definitely is growing faster in the y direction than it is in the x direction. So, and you don't have to know how to use these calculators. They're just giving you a visual representation. So because those are all jumping up by a factor of 3, this would not be a linear situation. Okay, it would be growing too fast. It actually is looks like it might be creating a calculator. So, so things to know. X and Y can be added or subtracted. X and Y can't be multiplied together or divided. So that divided, remember, is a fraction. Now, I could have x over 3, and that's fine. I just can't have 3 over x. I can't have x in the bottom or y in the bottom. I can't have a square root sign with x or y, or both. I couldn't go x raised to the y or y raised to the x. These are all, so this is a can, but these are can'ts that are taking place. Okay, and then obviously if you have log of x or natural log of x or sine of x or cosine of x, any of those things are not going to be linear as well. Okay, so linear has to be added or subtracted. You could have multiple x's and multiple y's as long as you can combine them. X and y can't be raised to a number other than 1. So I can't have x to the third and y to the fifth. That would not create a linear situation. You just have to have x and y. It could be 3. It could be 3x. It could be 7x. It could be negative 2x. It could be negative 4/5 x. Things like that. Those all work. So let's see. So linear, you have lines of all types of things that take place. Nonlinear are things like this. These are all nonlinear ideas, exponential ideas, exponential decay. Those are all nonlinear things. Linear means it's a straight line. It could be rising to the right. It could be dropping to the right. It could be the exact same horizontal line. It could be a vertical line. A vertical line is not a function, but it's still a line. All right. So discrete versus continuous. We've talked about discrete and continuous. Discrete is like you're counting items. The graph are dots or points. Continuous means it would be a smooth type of line. Okay, continuous, that means you would include everything on it. Okay, the independent variable would be the x value, which we would call the domain. The dependent would be the y value, which we would call the range. Okay, determine if the domain of the function is discrete or continuous. The cost to enter a haunted house depends on how many people are in your group. Okay? So even if you had a really short friend that came with you, do they still charge that person the same ticket? Yeah, so this would be discrete data. Okay? So if you had the temperature of Stirrup's classroom on Monday was this, on Tuesday was this, on Wednesday was this, the temperatures might be going up and down and fluctuating, but all of the temperatures in between would take place, so that would be continuous. So discrete would be you're counting people going to a haunted house. The amount of money made at the pumpkin patch depends on the temperature each day. Temperature, discrete or continuous? Continuous, yeah. Okay. The weight of pumpkins is a function of how much water they are given. Do I know if I go and use my water hose on a pumpkin patch, do I know exactly how much water I put out there? Oh, it might have been on for 10 minutes, but I might have had it on high, medium, low, turned it up a little bit. So this would also be continuous. Pumpkin patch kind of fits in with Halloween. Manuel, we're not doing any notes today, buddy? Manuel, you gonna sleep? Go to the nurse, you need to go to the nurse. You're not gonna sit here and sleep though. You awake, sunshine?
Yeah.
Where's our notes? No, it's not on your phone. If you don't want to be here, you don't have to be here, man.
I do.
Okay, but you're not doing notes. Dude, you're now checking messages. turning your phone off? I want to call yeah on that one. All right, pumpkin patch. Yay, we got pumpkins. All right. This is on your notes, right? Yes. Let f of x means the same thing as what letter? Y. So I'm just going to put that as y. Be the percent on the next math test where x is the number of hours study for it. X is the number of hours study for it. Okay. Okay, X is the number of hours. So what would the meaning of this be? What do you think? Yeah. What would this be? Yeah. Keith?
I think that's 0 over
Do what?
0 hours.
Yeah. So I studied 0 hours. So I earned a 55. Okay, so I didn't study, got a 55 on the test. Okay. Ooh, this one looks a little different. What do you think that might mean? Go ahead, Keith.
Studied 5 hours.
Uh-huh.
And then you got a, wait,
They're the same thing though, right?
they're both out.
They're both hours. So what this means is if I studied 5 hours, which is an ungodly amount of time to study for a test, you get a certain score. If you studied 6 hours, you would have gotten the same score. So did it matter that you studied 5 or 6 hours, which again, it was way too many hours to study for a test? This just means that the data would be showing that if you studied for 5 hours, you would get the exact same score as if you studied for 6 hours. So save yourself an hour and go get some McDonald's. Okay, this one, it's done the same way, but it has an inequality. What do you think it means? Yeah.
If you study for 2 hours, you get a less percentage than if you do.
Perfect. If you study 2 hours, you get lower score than if you study 3 hours. Something like that. This just means if you study for 6 hours, same score. And this shows if you study 0 hours, you earn 55 on quiz or test or whatever they're calling it. Now, guys, we all know there's that one kid, and they always exist in some class, that didn't study, but you got their ace and everything. Happens. But we're not saying that with our data. They're just saying, hey, if these types of things happen, this is what we are seeing from it. Maybe we collect, I don't know who's collecting this data. Again, this is fictitious. But I have seen tests where you grade the test, and then you find out from the student how much did they actually put into studying. And so maybe they collected it that way. They created, hey, on the X, we had hours of studying. On the Y, we had the percent grade. Yay. And maybe we show some sort of linear correlation. Okay, and I'm actually going to try, this is on page 107 on the homework, problem number 9. And I just want to do problem number 9. You have X, you have Y, you have 4, 8, 12, 16, 20. And they have a -4 here, and they have a 12 here. That's one question. And then you have another question. You have X, Y, -2, -1, 0, 1, 2. You got 20, and then you have 10 here. All right, so we have some unknown values that are going to go here, here, here. So unknown here, here, and here. All right, fill in the table so it represents a linear function. Okay, so if we look at the x, I add 4 each time to get up there, right? Do you agree with that? Add 4 to 4, you get 8. Add 4 to 8, I get 12. Add 4 to 12, I get 16, so on and so forth. Okay, so this has got to count up by the same rate. So if I go from -4 to 12, so think about it on a number line. You have -4 down here, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Think it's +8 each time? All right, let's see. If I add 8 to -4, so +8. Let's see if this is right. I get to 4. Add 4 to that, I get to 12. Add 8 to that, I get to 20. Nope, wouldn't be the +8. I like your idea, though. Let's try something else. +8 was a good place to start. +6? Okay, let's try +6. So if I add 6 to -4, I get to 2. If I add 6 to that, I get to 8. If I add 6 to that, I get to 14. No, getting closer. 4? +4. If I add 4 to -4, I get to 0. 4 to 0, I get to 4. 4 to 4, I get to 8. 4 to 8, I get to 12. Yeah, we added 4 each time. So the rest of my thing should have been a 0, a 4, and an 8. And just by doing that, we were able to find the pattern. We just used a little bit of logic to get through that. Okay. All right. That's the first part of number 9. Second part, looks like I'm adding 1 each time here. Agree? Oh, okay. So my first term is 20. My third term is 10. We need to create the right pattern. What would happen if I were to go, say, -5? 20 minus 5 is 15. 15 minus 5 is 10. 10 minus 5 is 5. 5 minus 5 is 0. So you're just kind of trying to see if you can have a pattern where you're adding or subtracting the exact same amount. That goes with that. Okay, that's good. Okay. Cool. I want to give you the opportunity to work on this. So page 107, 108. 108. Let's see. It's 11. All right, you got some time to start on that. Get it out, see if you can figure it out, decipher it. We'll check that off come tomorrow. And just know tomorrow I will not give you an assignment over break. We would probably have something that we will do in class and get done by the end of class. Okay? All right.